Yes, Bunty, we will take actually. After this combination circuits, we will enter into sequential. There we'll see latches, flip-flops, difference between them, then counters, shift registers, then static timing analysis, setup time, hold time, all those things we'll see. Okay, uh, is the PPT on? Okay, guys, can you see? Yes, yes, yes. ADC, DAC, everything will be taken. Yeah. Various types of ADCs, various types of DACs, all the problems. Okay, can somebody confirm whether you can able to see my screen? I just started sharing it. Okay, thank you, Bunty. So, for some of you who joined just today, these are the things that we discussed last week extensively about prime implicants, redundant prime implicants, then, you know, essential primes, all those things. So today we will talk about a little bit about the gates, and I just want to take two problems and then solve it. Okay, so try this problem. Minimum number of two input NAND gates required to build a two input XOR gate is. Okay, see, for this kind of problems, so before you taking up this problem, uh, let me, yeah, here only I write. See, you take this. Now, for example, when you talk about XOR gate, before even entering into XOR gate, to identify minimum number of NAND gates, right? This is the format that you will be interested in. To get a minimum number of NAND gates, you have something called F is equal to A plus C, something like this. If it is in this format, that's very easy. Okay. How, sir, why you are saying it is very easy? Very simple. You know, it's an AND operation, right? NAND means AD complement, right? Something like that. Let me change the color. Here you have AB plus CD. I will take double complement of this. What will happen? AB complement, CD complement, whole complement, correct? See, this is AB plus CD by virtue has converted like this. So what is very easy for me now? It's look like K dot M complement. What is K? Just AB complement. What is M? CD complement, right? Now I can easily write. To develop F, I need K and M NAND operation, right? K, M, F. To get K, what I need? AB NAND operation. To get M, I need CD NAND operation. That's simple. So this is the most favorite format for for getting minimum number of NAND gates. Now, suppose if I have, let's say something like this, KA plus KB. Same thing, right? I can have I can have A and K as an input, B and K as an input, and again give it to this guy. You will get Ka plus Kb. Now you can join these two and then say this is K, that's all. Correct? So this is the format that you will be looking at when you want minimum number of NAND gates. Okay, or also say I can say SOP form kind of. Now let's go back to right. Remember this AB plus CD thing. Now what is that you want? XOR operation, right? Zero 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 one one zero one one. This is XOR operation. So I can write generally A bar B plus A B bar. Now this is how people start with. Right? But if you start with this, you know, you will end up getting more number of gates. Let's say what will happen is, just to go with this, you have A bar B, you have A B bar, and this is how you will get A bar B plus A B bar. But for this A bar and B bar also, okay, you need to have one more NAND gate to generate A bar. To generate B bar again, we need to have one more NAND gate. So overall count will be 5. Let's say 1, 2, 3, 4, 5. But there is one more way. What is that? If you look at another format, let's say M, this is M1, right? This is M2. We have already seen this actually extensively. Or you can come to my YouTube channel. There we talked about SOP form, canonical SOP, canonical POS, simplified, very much simplified. Anyone can understand. So F can be written as either M1 plus M2 or M0 plus M3 whole complement. This is M0 into M3. So what is M0? A plus B, right? Because M0 is nothing but no complications. See that video, you will understand. Just complement that. A bar plus B bar. Now you can see this. You can take A plus B into this A bar plus B bar can be written as A or B whole bar. Yes. Ah, sorry. Hello. I didn't started, man. Focus first. Come on time. Okay. Eh, okay. So Tanmay, I think we started this, in middle of something. Please join the call on time. So now this is A dot B whole complement. I can write it as Ka, K, just K. K equal to A dot B whole complement. So what I'll get Ka plus Kb. Now we know we got into this format. Why we got this? Just one step below. You have this AK. We have already seen this. This is K. This is B. Then you have one more NAND gate, right? But what is K? A dot B whole complement. Correct. So this is AB. You see this now. Here number of gates are 1, 2, 3, 4. 4 gates. Here 1, 2, 3, 4, 5. So you take either this form or this form. Okay, anything is fine, no problem. So here you took it, and we have, by coincidence, we have this A dot B already coming up there. So we just try to make use of that. That's how we have reduced it. So the answer is option C. Right? So try to get in this format. Okay, something like this. Okay, AB plus CD format. Now, let's move on to the next one. Minimum n number of 2 input NOR gates required. To realize 2 input XNOR gate. Now, for NAND gates, if you take this kind of format, AB plus CD will give you minimum number of NAND gates. But for NOR, you look at A plus BC, something like that. Why A plus BC? Let's say, for example, if you take A plus BC, this can be written as what? A plus B into A plus C. Now you take double complement of this so that F value will not change, and you apply De Morgan's law. You can take A plus B complement plus A plus C complement, right? Whole complement. What is this? M plus N complement. What is M? A plus B complement. What is N? A plus C complement. What is this? We can have a 2 input NOR gate. Here you can take one more 2 input NOR gate. Overall, I can take one more 2 input NOR gate. Let's say, what is F? M plus N whole complement, right? Let me take the NOR gate. M, N, this is F. What is M? A plus B complement. What is N? A plus C complement. How many? 3. For A plus BC. I am not talking about NOR, XNOR operation. Okay, so that's how A plus BC is the right format. Okay, for 2 input NOR, this is the format that you will be looking at, because internally, the structure wise, it will give you the minimum number of 2 input NOR gates. Now use that concept and try to find out 2 input XNOR operation. For XNOR operation, again you will end up getting answer as 4. So for XNOR operation, you can consider AB plus A bar B bar. Now you look at this. Look at this. AB plus, I can write A bar dot B bar as A plus B whole complement, right? This you consider as K. So what you will get? AB plus K. Okay. Now the way we have done earlier, similar thing you can do for this also, right? You will end up getting 4. Okay, so option B is the right answer. I don't want to spend much time on that. I just want to give you emphasis. Okay, these kind of problems are existing. Okay, that's one thing. Okay, next. Let's go to multiplexers. Okay, this is, what is this called as? Op amp, right? And this is in open loop op amp. This class we will majorly see multiplexers. If possible, time permits, then we will go to decoder and all. Maybe next class we will see what are different problems, tricky problems involved in decoder, encoder, priority encoder, very important, and then demux, and yeah, those things we will see in the next class. This is for some of you who doesn't know about op amp, it works like this. Okay, this is V1, V2. If V1 is greater than V2, then V0 will be logic 1. If V1 is less than V2, then V0 is 0. Okay, like a comparator, just a basic comparator. Any answers? Yeah, if V1 equal to V2, you can say it is a 0. So the equation is very simple. V0 is A times V1 minus V2, right? If it is in open loop, condition is open loop. It's not a closed loop, Bunty. If it is in open loop, then you can say that it is 0 if V1 is equal to V2. If it is closed loop, there is a different story. That's a different story. Okay. Somebody said A, somebody said B. Okay. I think we need to look at the basics. Okay. So let's say, for example, okay, multiplexer, right? In many ways, you can understand this multiplexer. So you can see the name, right? You have multiple inputs. Okay. You are trying to access single output by having control. It's like a road, right? You have a junction. So many people are there traveling all over. Then there is a control guy called traffic police, right? Who will say, first you come, then you go, like something like that. In the similar note, we have something called a multiplexer. Let's say I'll take 4 input multiplexer. Let's say this is okay, and this is controlled by 2 pins. That is enough, no? How it is efficient? Because see, if these two are 0, then you pass this to the output 0 0. Okay, these are control signals. These are inputs, and there is only one output. Okay, only one input you can pass it to the output, right? So you pass this I0 pin, let's say 0 0. What is this 0 coming from? Now you have something like this is also called as select lines, right? You might be familiar with the select lines. Now S1, S0. Why I'm writing S1 and S0, I will tell you. So if you have 0 0, then I0 will be passed to the output Y, right? So let me write this here. Try to get the basics. If you don't understand, ask me to repeat. No problem. If S1 and S0 is 0, then pass I0 to Y. If S1 is 0, S1, S0 is 1, then pass I1. Where is I1? The data coming here. Then 1 0 is I2, 1 1 is I3. Okay, this is called as characteristic table. This is not called as truth table. This is called characteristic table. Anybody want to attempt why it is called characteristic table? Why not truth table? I2, I3. Now here that number, this 3 is coming because I am considering S1 as MSB, S0 as LSB. Very, very important. This is the most critical step for any multiplexer. Most of the majority of the people will ignore this. If S1 is 1, S0 is 0, S0 is 1, then I3, correct? Only if I consider MSB and LSB. If I convert 1, 1 binary into decimal, it is 3. Similarly, if S1 is 1, S0 is 0, right? 1, 0. If I convert it into decimal, it will become 2. Correct? Very, very important to recognize which is MSB, which is LSB. Right? We will see in a lot of problems, right? And you can see, okay, sir, what is this S1? Why this is 1 here? What is this 0? If you look at this, what is the conversion factor to binary to MSB? 2 power 0 into S0, 2 power 1 into S1. Okay, this is nothing but the powers. That's all. Okay, weighted sum power. You can understand like that. Right? This is one way of understanding multiplexer. Okay, looking at the diagram, block diagram or a schematics. Just look at this, right? Then this is in terms of table. Now in terms of equation, multiplexer output equation, right? Okay, what I can write? Y is I0, Y is I0 when S1 is 0, S0 is 0. How can I write that? S1 complement, S0 complement, I0. When S1 is 0, S0 is 0, Y is I1. When S1 is 0 and S0 is 1, then Y is I1 plus S1, S0 complement, I2 plus S1, S0, I3. So there are three ways of understanding multiplexer. One is in terms of block diagram, in terms of characteristic table, in terms of equation. Depending on the problem, right, you can think in one of these ways and then try to obtain the answer. Okay. Let me know through your chat box. Are you guys clear? Yes or no? Okay, great. Now look at the problem and then we will see a lot of problems and then issues in the multiplexer, right? Now look at this. See, now you have the answer in terms of logical expression, means you need to obtain the equation. That's it, simple, right? So now to obtain the equation, you need to know the inputs, right? You already know the select lines. You can write y is what? S1, S0, right? What is the equation, output equation? S1 bar, S0 bar, I0, S1 bar, S0, I1. Be clear, okay? There is I2 here. Don't get confused. S1, S0 bar, I2 plus S1, S0, I3. Here we are very clear. S1 is A, S0 is P. What we don't know about, what is I0, I2, I1, I3 and all those. Okay, let's find out. Now, the current drawn by the op amp is 0, right? We all know that. The current will not be drawn. So I can say that the entire current will flow through like this. So I can say all the resistors are in series. So what is the voltage across this? 3 plus 2 plus 1 is 6. So the voltage across this is 10 into 6 kilo ohm divided by 10 kilo ohm. Overall resistance is 10. So what is this? 6 volts here. So this point it is 6 volts. Here 10 into 3 kilo ohm divided by 10 kilo ohm, right? So this is 3 volt. What is this? 10 into 1 kilo ohm divided by what is the overall resistance? 10 kilo, right? This is 1 volt. Now what is the other side? Here it is 5. Here it is 5 volts. Here it is connected to 0. So 0 volts. Now non-inverting input has higher voltage compared to inverting. So output will be 1. Non-inverting input is having lesser voltage compared to non-inverting, inverting input means 0. Here non-inverting input has higher voltage compared to inverting. So 1. This I3 is already 0. So I1 is 1, I2 is 0, I0 is 1. Substitute those values. I2 and I3 are 0. I2, this is 0 means that term will be 0. I3 will be 0. Don't need to bother about that. What is S1? A complement. S0 is B complement. What is I0? I0 is 1. Plus, what is S1? A complement. What is S0? B. I1 is 1. So what is Y? Not is that this is not Y. Okay, sorry. This is some variable M. Output equation. Okay, I'm so sorry. This is just M. Okay, Y is what? M plus C bar. Okay, I'm so sorry. Hmm? So M is, this is just output equation of a multiplexer. A bar. Right? Because B bar and B, I can take it as common story. So Y is what? A bar plus C bar. I can also write it as A dot T whole complement. So option A is the right answer. Any questions? Any doubts? Let me know through your chat box. Is it clear? Okay. That simple it is. Okay. Be careful. So what you need to check out is check for select lines and check for I0, I1, I2, I3 very, very carefully. Right? Don't do the mistake. Otherwise, it's a shoe shot answer. Right? Okay. Find it out. What does Y represent? R operation, AND operation of AB, NAND operation of AB, none. What's the answer? AND operation. Okay. Again, you need to know the equation, right? To understand whether under or something like that. What is Y? I can write it as, if it is two inputs, then S bar I0. Let's say this is I0, this is I1, plus S times I1. Here S equal to B, I0 is 0, I1 is A. So B complement, I0 is 0, so this will be 0 plus B, I1 is A. So Y is A and B or B and A, whatever. This is just an AND operation. Very simple. Do this. What is Y in terms of A, B and X? These are XOR gates. Somebody said C. Okay. Someone said A also. Again C. Okay, let's see. Okay. So what is XOR operation? Let's say, for example, A complement B plus AB complement. Both the inputs are X only. X complement and X plus X dot X complement means this is 0, this is 0, this is 0. So what is the output of this? 0 complement X plus 0 X complement. Correct? 0 complement is 1. 1 and X plus 0 is 0 into something is 0. So this is X. So S naught is X. So what is Y? S naught complement into I naught S into I1. Here what is I naught? S naught is X, just now we found. I naught is A, I1 is B. Y is X complement A plus X into B. So AX bar plus BX. Option C is the right answer. Okay, try the ninth one also. Good. Very, very responsive batch. Same, you need to find, write the output equation for marks and then substitute those things. Again, I am writing S complement I0 S into I1. What is I0 is 0. I mean, sorry, I0 is B. The input connected to this, right? I0 is B. I1 is A. Oh, sorry. I1 is A, and let me hide this. S is A. So Y is A complement. What is I0 B plus S is A. What is I1? A. This is A plus A complement B plus A. What is A plus A complement B? A plus B into A plus A complement. A plus A complement is 1. That is equal to A plus B into 1. Anything into 1 is the same thing, right? A plus B. What is A plus B? R operation. Right? Yeah. A 4 by 1 multiplexer is given and F is A XOR of B. Then what are the inputs? I3, I2, I1, I0. Or we can do one thing. Yeah, do this. Yes. Any answers? In continuation to that, I will give one more problem, okay? Let's say I want to realize this using 2 by 1 mux. I have a 2 by 1 mux where the select line is B and I want to realize A XOR of B. What are I0 and I1? What is I0? What could be I1? Okay. See, these kind of problems, you don't need a, you don't need an output equation and all those things. Okay. Obviously, what you need is a truth table. Okay. Just this is a method you can follow. Anybody can solve this. Very easy actually. Nothing to worry about. Sure shot. 0 0 0 1 1 0 1 1. Correct. Now output is we know XOR operation. What is this? All right. So what they are saying? What are the select lines? A and B. Correct. So A is select line, B is also select line. The format is also correct. Okay. A is written as MSB, B is taken as LSB. If A is 0, B is 0 according to this. If A is 0, B is 0, this select line will be chosen, right? I0 will be selected. According to this, F is 0. That means that if I pass 0, that 0 will pass to the here. That's it. For 0, 1, what should be the output F? 1. That means put 1 here. For 1, 0, what is the output? 1. That means you put 1 here. For 1, 1, F is 0. If A equal to 1, B equal to 1, you make this line equal to 0, that will be passed to the output. That's it. So, what is the question? I3 is 0, I2 is 1, I1 is 1, I0 is 0. 0, 1, 1, 0. That's it. Now, next the question is little tricky. Same procedure. It is not that straightforward, okay? It's just we need to do some kind of trick. A, B, and F. 0 0 0 1 1 0 1 1. Same truth table I am taking. Little different, okay? So what is this saying? If B is equal to 0, I naught will be passed to F. We need to find out what is I naught. Now check where is B equal to 0 in the truth table. When B equal to 0, look at the output. It is 0 and 1. This is not constant. It is not 0 in both the cases or 1 in both the cases. So means this F is a function of A. Means if A is 0, F is 0. A is 1, F is 1. That means that F is just replicating on A. So I can write like this. I have B here, 0, 1. F. If B equal to 0, F is just replica of A. So I can just write this input as A. That's what the observation is, right? Now what happens to F is equal to 1? B equal to 1. You observe this case. If B equal to 1, again you see these two. It is not constant. It is either 1 or 0. Means you look at, now find out the relation between F and A. If A is 0, then F is equal to 1. If F is A equal to 1, then F is equal to 0. means it is a complementation of A. So I can just write A complement. That's it. So the value of I0 is A, value of I1 is A complement. Similarly, in the exam, they may ask you, they may give you select line as A, then they may ask you to find out what is I0 and I1. That is always there, right? So you understood this? Let me know through your chat box, yes or no. I0 is A, I1 is A bar, correct. Okay, all of you understood, right? Very good. Okay. Solve this. Let me see how much you have understood. There is a mistake here. Okay. Let me correct this. This is not sigma. This is pi. Capital M comes only when there is a product. Small m comes when there is a sum. So you need to find out what are the inputs to 0, 1, 2, 3, 4, 5, 6, 7 lines. If A, B, C are the select lines. Same concept. No change. It's the same thing. Any answers? Okay. Option B. Let's see. See, I'll just rewrite this thing here. S2, S1, S0, A, B, C, right? 0, 1, 2, 3, 4, 5, 6, 7. And this is f of A, B, C, T is equal to what? Pi m of 1, 5, 12, 15. Be careful. 1, 5, 12, 15. Let me cross check. 1, 5, 12, 15, right? Now, we got this, right? So, what we should do first? Form the truth table. How many inputs are there? 4 inputs, right? So, you will have 16 combinations. A, B, C, D, this is F. Right, 16 combinations. Yeah. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 0, 1, double 0, 0, 1, 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1, triple 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, double 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Anything I missed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. Now, what does this mean? At this particular places, f will become 0 because it's a max term, right? At 1, 1 is here, right? 1, it is 0. Then 101 is here, 5. What is 12? 1100, right? 15. What about remaining places? All are 1. Now, let's come to the analysis. A0, B0, C0. What will happen to F? A0, B0, C0, this combination. A0, B0, C0, this combination. These two combinations. What is happening to F? This is not a stable value, not a single value, multiple values. Now you need to find the dependency on D. So if D is 0, F is 1, D is 1, F is 0, that means that complementing. Complementing. Right? Next. 0, 0, 1. Where is 0, 0, 1? Here, right? These two cases 0, 0, 1. Now you see the F, irrespective of anything, F is 1. It is not dependent on D. So D bar 1. Let's see any combination. Correct. We already got this. Option B is the right answer. Because no other thing is matching. You can find it out also. Then 0, 1, 0. 0, 1, 0 is this combination and this combination. Again, it is a complement. D bar 1, D bar. Correct. Then 0, 1, 1. Okay. This one and this one. 0, 1, 1. F is 1. Right. Similarly, you can do and then find out. Right. We can stop it here itself with the two options. Two inputs itself, because that's not repeating everywhere else. Since none is there, I want to make sure that this is proper. So let's do properly because none is also there. Then 100. These two, right? Again, this is 1. F is irrespective of D. Then these two, 101. Again 1. Then 110. Okay, these two, 110. Okay, F is nothing but just repetition of D. Right? Then this is D bar. Correct? D bar 1, D bar 111, D bar. That's it. Correct. Option B is perfectly all right. So these are the many ways of understanding mulks. Okay, but more or less this is the same story everywhere, whatever the problem. Okay, you guys understood? Say yes or no in your chat box. All right. Thank you. Let's go to next problem. Do this problem. Okay, these are the different ways of asking a multiplexer. Yeah, any answers? Option A. Hmm. See, you can directly apply the output equation, right? So what is output equation? S1 complement H0 complement I0, S1 complement H0 I1, S1 S0 complement I2, S1 S0 I3. You don't need to by heart this, just write the output equation, like write the characteristic equation, you can derive it. So I1 is 0, so you can neglect this. I0 is X, okay? So S1 is Y, S1 is Y, S0 is Z. Okay, Y complement, Z complement, I0 is X plus 0 plus S1 is Y, S0 is Z complement, I2 is X complement, right? See this, I2 is here, X complement, this is X plus S1 is Y, S0 is Z, I3 is 1. So what is this? So now your F is a function of X, Y, Z. This is MSB. This is LSB. That is very, very important, right? So write in that particular format, change it. So X, Y complement, Z complement plus X bar, Y, Z complement plus. Here there is no X term only. So instead of writing 1, I can write X plus X complement and multiply. I will get X, Y, Z plus X complement, Y and Z. You know how to write, how to find the midterms and the number like uncomplemented form 1, complemented means 0, 0, right? And this is 0, 1, 0. This is 1, 1, 1. This is 0, 1, 1. What is this? M4 plus M2 plus M7 plus M3. Okay, if you sum everything, sigma of 2, 3, 4, 7, ascending order, right? 2, 3, 4, 7. Option A is the right answer. Okay, this is how some questions on multiplexer are like that. Okay, so we have few problems on decoder, something like this. Okay, I'll just explain the decoder. Maybe next week we will start solving the problem, right? So what is the decoder does? It converts binary inputs to discrete outputs. Okay, kind of encryption. Okay, you don't want to transfer the data as it is. You add some kind of bits so that you change the data and then transfer that data. Okay, so you have a binary input. Let's say, for example, 2 input binary, and you can convert it to 4 bits, 4 outputs. So how it works is, all right, let's say this is the outputs are D0, D1, D2, D3. Very simple working. How many inputs? 2 inputs. How many outputs? 4 outputs. If AB is 0, 0, if AB is 0, 0, what is decimal equivalent of 0, 0? If I consider A as MSB, B as LSB, decimal equivalent is 0, base 10, right? So this particular output will be 1, remaining will be zeros. Okay, D0 is 1, remaining will be 0. Here I should mention MSB, LSB. Otherwise, what is the weight of this A 2 power 1. That is the weight of this B 2 power 0. So I can write the powers. Both the way. Whatever we have seen in the case of multiplexer, same thing we'll write here also. Suppose if I take 0, 1, 0, 1 conversion to decimal is 1. So D1 will be 1, remaining will be zeros. 1, 0 is D2 will be 1, remaining will be zeros. Both are AB 1, 1 means D3 will be 1, remaining will be zeros. Okay, this is understanding of decoder. Or if I want to write D0 in terms of AB, what is D0? D0 is 1 when A is 0, B is 0. That's it, right? I can write A bar, B bar. D1 is A complement B. D2 is yes, AB bar. D3 is A and B. Correct? Now, if I write in terms of midterms, D0 is nothing but M0, right? D1 is nothing but M1. D2 is nothing but M2. D3 is nothing but M3. That's all. This is all the discussion about the decoder. Nothing less, nothing more. If you know these three perspectives and these three views of decoder, you can solve any problem. That's for sure. Okay, so let's take a break now. See you guys in the next week. If you have any questions, you can ask me. Thank you. Yeah, recording is available over this same website. Not a problem. Okay, Ramesh. Welcome. Welcome, Sai Prakash. I'll wait for 1 more minute. If you guys any question, then you can ask me. Otherwise, I anyways end the session. Yeah, I can. This is my mail ID.